Okay, guys, we are in Advanced Math Trig, mods 2, 3, 4, and 7. We're going to start graphing specific functions. Keep in mind, if you think back to yesterday when we did our little library of functions and the note said that a skilled calculus student has a nice mental library of functions, has the ability to look at a function and sketch that function as accurately but yet as quickly as possible. And guys, I'm telling you right now, our goal on every function, not only today or tomorrow or the day after, as we progress through specific examples of different kinds of functions you should be able to sketch quickly, is to not use a calculator. You are not, when you do your 4 homework assignments, going to type in y equals blah, 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 hit graph, and draw a picture of what you see on your screen. That's not what we're doing. Half of the AP Calculus test is non-calculator driven, and 90% of the time, any question involving a function and, what's the slope at this point, or what is the area under the curve from here to here, or rotate it around an axis, create a 3-dimensional shape, and find the volume from here to here. You've got to be able to quickly sketch the picture based on your library of functions that you were taught this year. So let's make this simple. Today, I almost feel guilty. This is so easy. We're going to be done here probably in about 7 or 8 minutes. But we're going to make our way through that entire 17 function library of functions that we created yesterday and look at specific examples of each kind to make sure you can, again, the 2 key words here, quickly yet accurately sketch all these graphs without touching a calculator. It's almost like we're going to have a race, ready, set, go, of who can look at a function, graph it the quickest, but yet have an accurate picture on your paper so that we can then move on from there, depending on what the questions are we're going to attack, whether it be pre-calc, college credit plus pre-calc, or AP calculus, or regular calculus, or college algebra even. Who knows if they're ever going to teach specifics of these functions again. You're expected to go in with this knowledge, okay? So here we go. Generalities. Notice today it just says linear and quadratic. I'm going to make my way through that entire library again. And the first pictures we drew were linear and then quadratic or curved functions. So we're going to do 2 linears, 2 quadratics, and we're done. All right, but when you try the problems on your own for homework and send me a picture of your 4-problem daily assignment, you've got to do the problems just like I'm doing. I want to get you trained in the mental approach of how to attack and set these up by hand. You are not using a calculator. You get 1 point for showing the proper process of attacking and sketching the function, and then of course 1 point for the finished product or picture. Okay? That's how we're going to do this every day. All right, generalities. Number 1, no matter what type of function is written in front of you, you know in, quote, standard form, it's always going to be what? Y equals and then blah, blah, blah. So no matter how complicated a function or a picture can look, you know your initial algebraic goal is to get y by itself. So real quick, on number 1 here, it says negative 2y equals 6. By the way, today is 5/12/20, top left corner. Tuesday the 12th, so here we go. Number 1, obviously if I'm getting y by itself, I'm going to divide by negative 2. The negative 2's cancel, and I end up with, I'm just going to put it over here because we need room for our sketch every time. Y equals, obviously, that's negative 3, okay, freeze. If I said, give me a name of that type of function from our library, remember y equals some constant? There's no x involved here. Oh, that was called a constant function. So for me to graph this, I don't need to create any XY table. I don't need to do any work with MX plus B. I sketch a picture. And if it's a constant function, y equals negative 3, of course I go to my y-axis, and it says my y value has to equal negative 3, doesn't it? So I go down to negative 3, draw my line, my horizontal line right through there, and I'm done. Y equals -3 is a constant function going horizontally right through -3. If you would ever end up with x equals, let's say, -3, you would have gone to the x-axis, gone over to -3, and drawn a vertical line through there. Now, that's not included in our library because that would be a what? Vertical line, which is not a function because it doesn't pass the vertical line test. But just a quick note that, of course, that's how you'd handle that. Okay, number 2. I've got this equation. There's a y involved. My job is to get that y by itself. So again, algebraically, as quick as you can, you don't have to show a ton of work. Of course, I'm just going to use arrows and shove that guy over. So I've got what now? -3y equals, if I add him over to the other side, 2x minus 15. Again, I'm leaving room for a graph here. If my goal is to get y by itself, I divide by -3. This is simple algebra 1. Again, I don't want to insult your intelligence here. We're just going to do due diligence and go through every function in the world that you're supposed to know how to graph. The -3's cancel. Now, careful. If that's a +2 and I'm dividing by -3, of course, a positive over a negative gives me -2/3 x, and then a negative over a negative gives me a +5. There, I'll circle my function that's in standard form. I probably should have circled this one because what I'm looking for is, number 1, is your function in standard form? And then do you use the right procedure to graph it? And then do you graph it accurately? Now again, here procedure-wise, I don't need to see a table, do I? This is the old y equals mx plus b, right? It's just a linear function. Always, of course, we look at the last number called our y-intercept. If my y-intercept is +5, I'm going up 5 on the y-axis and putting a dot, right? That's where it crosses the y-axis, my y-intercept. I have a slope of -2/3. -2/3. Remember, this is my rise and my run. So if it's -2/3, remember, the negative does not go with both numbers. You're not going to go down 2 and left 3, because that'd be a negative and a negative, which would have been a positive slope. So always take the negative and just pretend it's attached to the top number. That way you're always finishing by going to the right. So my rise is -2, down 2, and I'm going to run 3. 1, 2, 3. Did it. Got my picture. Connect them up. I knew it was going downhill because I had a negative slope. Okay, and we're done. Let's go to number 3. You certainly on your library of functions would recognize this is already in standard form, right? Because y is by itself. I see an x squared, so I'm thinking quadratic function. Quadratic functions are always parabolic, right? Parabolas. And because it's a positive 2x squared, you're thinking I'm about to draw or sketch a smiley face. So picture-wise, I'm going to go down here and give myself plenty of room to draw a parabola, a quadratic function. Now, careful. If you were going to make a list of important points that you need on your quadratic function to accurately draw it, don't you need to know these 3 things? Number 1, where does it cross the y-axis, right? What's its y-intercept? Number 2, when I draw a smiley face, I'm trying to be as accurate as I can and as quickly as I can. I need to know where does it cross the x-axis? What are its 2 x-intercepts or roots? And of course, when you draw it, you need to know where is my vertex. Now, my best piece of advice, here's the best way to sketch this as quick as possible. Go ahead and make an XY table. You're not going to need a ton of room, but watch. I always start by plugging 0 in for the letter X, right? Because think about it. If I said, draw a parabola, where does it touch the y-axis? Doesn't its y-intercept have to have an x-coordinate of 0? So step 1, plug 0 in for x, obviously 0 squared is 0, and 5 times 0 is 0, leaving me with that last number, -3. So at least to get my foundation going, I'm going to go down 3 for my y-intercept. Now, you guys have always had a formula. Remember this guy, -b over 2a? Doesn't -b or opposite of b divided by 2a always give you the x-coordinate of your important vertex? So my vertex is going to be at, now remember, that means opposite of b. What's the opposite of -5? 5. And then 2 times a, of course, would be 2 times 2, which is 4. So my vertex is 5/4, comma, to get the y-coordinate of that important vertex, I got to plug that into my function. Now, again, I don't have a calculator here. So stay with me, mentally stay with me here. Watch, remember, we're trying to do this as quick as we can. I'm going to ignore the 2. If I take 5/4 and plug it in and I'm supposed to square it, 5/4 times another 5/4 gives me what? 25/16. So this is me chicken scratching. I've got 25/16 times 2. The 2 would cancel and the 16 becomes an 8. Don't be afraid of mental math. So 25/8 minus, of course, what's 5 times 5/4? That's 25/4 minus 3. Common denominator between these two, isn't 25 over 4 going to turn into what? 50 over 8? You with me? 25/8 minus 50/8 is -25/8. And then there's a minus 3. So guys, you agree? That's really what? -3 1/8 minus 3, which is -6 1/8. I just had to have a quick estimation of where the vertex was at. So I'm actually going to go right 1 1/4 and down, oh my gosh, down 6 1/8. There's my vertex. And finally, as I draw this picture, again, as accurately as I can, I'm picturing it, but where does it touch or cross the x-axis at? Of course, that's, okay, my x-intercepts. Obviously, if I'm touching the x-axis, my y-coordinate now is 0, isn't it? So you're now plugging 0 in for the letter y when you do some chicken scratching here. So this would say 0 equals 2x squared minus 5x minus 3. I plugged 0 in for the letter y with the goal of finding my x-intercepts. Of course, you're going to factor this, math mafia it, whatever you guys call it. If that says 2x squared, I'm going to go 2x and 2x. I have a minus at the end, so my signs are different. And 2 times 3 is what? 6. And the factors of 6 that add up to -5, I'd put a 1 there and a 6 there. And so since I've got a dot connection equal to 0, I split those apart and set them both equal to 0. 2x plus 1 equals 0. 2x minus 6 equals 0. So x equals -1/2. And what? X equals, I would add over the 6 and then divide by the 2. X equals 3. So, oh my gosh, one x-intercept is 3. The other x-intercept is -1/2. The foundation is set, and I've sketched an accurate parabola looking like that. Okay? All by hand. Mental library of functions. I can confidently and quickly and accurately take any function and sketch it next year. Okay? Finally, number 4 is another quadratic function. Yes, it's in standard form, but now there's a negative in front, so I'm thinking frowny face, right? So when you go to draw this one on your assignment, you're still going to make a table and do what first, right? Creatures of habit, have an attack plan. every time you draw a parabola, I want to know where does it touch the y-axis. Put 0 in for x. 0 squared is 0. 2 times 0 is 0 plus 8 gives me 8. So I'm going to go up 8 and put it out. There's my y-intercept. I wonder where the vertex is at. I'm going to use the formula negative b over 2a. So negative what? 2 over 2 times a. Well, that'd be 2 times negative 1, which is negative 2 for a vertex located at 1. Remember, that's my x-coordinate. I take 1 and I plug it in for x. Now, careful, you're not squaring negative 1, guys. There's really a negative 1 dot connected to the x squared, so watch, you're only squaring the number you put in for x, right? Don't mess up simple math, that's crazy. 1 squared is 1, and there's a negative in front of that, so I've got negative 1 plus 2 times 1 is 2 plus 8. Add all that together, and I get what? 9? So I'm actually going to go right 1 and up 9. There's my vertex. And just like the last question, as I start to draw this picture, of course, I'm going to go through my y-axis, keep coming down, and eventually touch the x-axis. Agreed? And then draw a curve this way and touch the x-axis. What are my x-intercepts? To answer that question, and we're done, you got to plug 0 in for y this time. Now careful, that gives me 0 equals negative x squared plus 2x plus 8, correct? Guys, you're not going to factor this because the leading term is a negative number, right? You don't factor something, a trinomial, when the first term's negative. You factor out a negative 1, or in this case, because there's an equal sign, divide both sides by negative 1, giving me 0 equals, and all that does when you divide by negative 1 is what? Change all the signs to the opposite. X squared minus 2x minus 8, and now that should factor into x and x. Signs are different. And I'd use what? Plus 2 and minus 4 here. And I get my middle number matched in the middle, negative 2. Take that dot connected product since they're equal to 0 and do the old let's split them apart trick. So we're going x plus 2 equals 0. X minus 4 equals 0. So x equals negative 2 and x equals 4. Ah, there's one x-intercept coming down through that guy. And x equals 4. There's my other x-intercept looking like that. And I did it. And then guys, remember calculus-wise, next year they could certainly say, what's the area of that function from between that function and the x-axis? From 0 to 4. So if you didn't know that that was touching the x-axis at 4, you wouldn't know to color that in and find out that total amount of area. So thinking back to last week, we would integrate from 0 to 4 and then the name of that function using your integration tricks that I taught you. Here, if I integrated from 0 to 3 and we colored all that in, wouldn't that area all be located under the x-axis? And therefore, when you did integrate to find the area, you would actually get a negative answer like you did on some of your homework problems because the area you colored in was located below the x-axis. So quick, accurate sketches on all functions is important. We've scratched off linears and quadratics from the list today. Okay? So this is a valuable, good review lesson for the next several days on attacking all types of functions. And mentally, how do you approach them to draw them as quickly and accurately as I can? So great job. You're going to try these 4 problems, 1, 2, 3, and 4. Since today is Tuesday the 12th, this is due Wednesday the 13th at noon. So big deal. You got plenty of time to sketch and graph as neat as you can these 4 problems. Guys, when you send your picture, take the picture directly over top of the problems and then send it instead of from an angle or the side where I can barely read them. Make it easy to read. I got to do 100 of these a day, and take good pictures, okay? Your expectation, copy the problem, get Y by itself if needed, do the exact procedure I did on the notes, sketch it by hand. You're not touching a calculator, and you are, hopefully, please do your own work, do the best you can, big deal. This will be an 8-point assignment. 1 point for using the correct procedure and technique, and then 1 point for your finished picture. It's like a little 8-point daily quiz or daily grade that will keep adding to the grade book and be done by the end of next week, okay? Great job. We'll see you tomorrow.